Good morning, everyone. Thanks for joining us today. My name's Dr. Martin Westgate. I'm here from the Atlas of Living Australia. I didn't realise we were going to be in this room, so I'm a little overwhelmed to be in the giant plenary space, but it's lovely to have you here. We're here to talk about monitoring matters. I'm very excited to be able to host this. A little bit about me before we get started. I'm an ecologist and software developer, previously at the Australian National University, now with the Atlas of Living Australia. This is our first time at the ALA contributing to this conference and attending this conference, so it's been wonderful. Thanks so much for making us feel welcome. The ALA is based at CSIRO Black Mountain, so I'm very privileged to live and work on Ngunnawal country and Ngambri country. Like the previous speakers across this whole conference, I'd like to acknowledge those people and their elders past and present and any other Indigenous people in the room today. So, monitoring, huh? Look, it's been a focus of my career thus far to have an interest in monitoring and the monitoring of biodiversity in particular. A difficult and interesting space, and one that's growing in importance, particularly with discussions about nature repair market and such things as well, but also, state of the environment reporting, for example, would be in a much more sorry state if it weren't for the efforts of people doing biodiversity monitoring around the country. And it's a big focus for us at the Atlas to find ways to support those monitoring programs and for people to share data from those monitoring programs in ever more richer and more informative ways. So it's a real privilege to be able to share this panel today. Fortunately, though, you don't have to hear me talk too much. We have a distinguished panel of guests and speakers who are at the front lines of doing this science and research. So I'd like to start by introducing them to you today. We have John Evans from Sustainable Farms at ANU. Just wave, John. Thank you. Lovely. Aimee Bliss, Tasmanian Land Conservancy. We've got Shawn Capararo from New South Wales Biodiversity Conservation Trust. And we have John Fargher from Yundi Nature Conservancy. Hope I've pronounced that correctly. Lovely. Just some administration. I'm sure you've had plenty of this so far. Please add any questions in the app. We have plenty of time for discussion at the end. We had planned to have Jane Coram, Head of Environmental Information Australia, join us today, and she is unable to. So we have more time for questions, so feel free to drop them in the app. And with that, I'll hand over to Dr. John Evans.
Hi, so my name is John Evans. I've been roped in to do this talk in place of David Lindenmayer, who sends his apologies. He's been whisked away to give some advice at Parliament. And one of the reasons why David wanted me to do it is because I'm an ecological statistician who works within the Sustainable Farms team, and he wanted me to express the importance of good statistical design in anything that we do when it comes to monitoring. So, the first thing I wanted to discuss is why monitoring matters. Well, it is fundamental to evidence-based environmental decision-making, and it documents and provides the baselines with which to evaluate the change. If we have a restoration action, how do we know where we've made an ecological change? And also in ecological timescales, it's very difficult to see an immediate change after a very short space of time. So a long-term monitoring, 8 to 10 years, it could take that long before any sort of restoration has any sort of ecological effect. And I just wanted to talk about a paper that was published in September. This isn't our group, this is a Lamont et al. In Science. And these authors, they looked at the sustainability reports of 100 transnational companies that were positioning themselves as environmental leaders. This is great. They said they were going to undertake restoration that was beyond what their legal requirement is to do. But what we see from this is that out of the 100 of these world's largest businesses, 66 of them actually report undertaking restoration, but only, when it comes down to it, only 4 of them actually report the results of any monitoring that they've done. So we don't know whether they actually have done these things. So they may have done, that's great, I'm not saying that they wouldn't, but it's very important to actually monitor what they're doing. So David David, in his book in 2014 with Jim Likens, he talks about 3 types of general monitoring. There's the curiosity-driven or passive monitoring, which is not really question-driven. It's just sort of doing something out of interest. And it has no real use over the long term. It could be interesting. Then there's mandated monitoring, which is just passive monitoring over a long time scale. It's very rigorous and can be useful to see changes over time, but it doesn't actually have any a priori questions about what a restoration action might do. And then there's the Rolls-Royce, which is the question-driven monitoring, which is stipulated by government legislation or political directive. It can be strictly carried out, but it's based on good statistical design with controls and treatments, and it has a priori hypothesis about what needs to be done. So, talking about this last type, what characterises a good monitoring program? So, first of all, you need to know what actions you do, and what effects they'll give. And here's a very simple conceptual model of a restoration action that might happen in an agricultural setting. You might fence off an area to reduce the grazing, and then that might result in vegetation change, which then might result in a biodiversity change. We can test all of those separate things in a statistically robust manner that contains good replication, and able to get a good idea that these things actually are happening, not in isolated incidents, but they are happening overall. And they also contain controls and treatments, so we know the counterfactual of actually what is happening. And this might be in a BACI design, which is a before and after control impact design, where we've got what happens before the action, what happens after the action and during the time between the action, and then what is the counterfactual of if we don't do that action at the same time. You need to select the appropriate entities to monitor. That could be any aspect of biodiversity, or it could be water quality in dams. And you need strong leadership to keep these monitoring programs going. Now, we have strong leadership in David Lindemeyer and also Michelle Young for Sustainable Farms, who tries to keep these monitoring programs going, which is no mean feat to get ongoing funding to do it. And you need to use the data frequently to test it, to make sure that it's doing its job, and you need to go through peer review in the scientific literature, which is actually a really hard process. And you need to maintain the data integrity. If you don't maintain the data integrity, then you confound things with time or with treatments. You need to make sure that everything that you collect is comparable between everything. So, going back to what we do, we have the Sustainable Farms project, and our area encompasses this region in Australia, approximately 15,000 farmers, running 9,000 businesses, 30% of Australia's sheep and lamb production. It's a very important area to Australia, as I'm sure everybody knows. Now, we have a number of long-term monitoring sites within here, and they're all collected in very similar ways, so we can compare data between them. But they've been going for 25 years, 838 sites varying in condition and management, from tree planting to mixed farming landscapes, protecting remnant trees, protecting waterways, enhancing remnants with plantings, and remnant paddock trees. And we monitor lots of biodiversity, vegetation, animals, habitat attributes, and this all allows us all to actually figure out what is going on in these projects. And we've got several different projects on the go. We're enhancing farm dams, we're establishing plantings, protecting remnant woodlands, etc. So I'm going to give a couple of examples of some studies that we've published in the scientific literature on plantings. So, what makes a good planting? Attributes of a good planting are the location, the size, which is but not as important as context, the shape, and what it contains. Logs, large old trees, understory, mistletoe, dams, and whether it's fenced and not grazed. And we've set up a study where we looked at grazed versus ungrazed plantings over time. And as the plantings age, a lot of the fences that were put up for these plantings, they started to deteriorate, and the grazing, and then as a result, stock come in and graze. And this alters the leaf litter and mid-story cover. And we have what's here called, that David likes to call a horrendogram, which is a path analysis which shows the effects of various things. So if we concentrate just on the bottom bit of it, and what we've shown here is that uncontrolled grazing reduces the amount of leaf litter, so that negative number there, 0.85, is reducing the amount of leaf litter, but also in turn, a leaf litter improves bird species richness. But the composite effect overall is that uncontrolled grazing has reduced bird species richness in these plantings. So did the intervention work? Well, yes. Native shrub ground cover increased, native species richness increased of vegetation, percentage of overstory regeneration increased, and percentage of bare ground decreased. And what did this do to the birds? Well, it improved species richness, and we compared that with good treatments and controls, so we knew exactly what was happening in areas where we didn't have these planting treatments. It changes the vegetation, and vegetation changes the birds. And it's small woodland birds, which we know are in some strife, they were impacted most, they benefited most. So it worked. So here's another study that we did. So as you know, as many of you may know, the noisy miner is the cause of beating up, basically, lots of the small woodland birds in Australia. They're incredibly aggressive. They they guard their nectar resource, but they're a native species, so it's strange. But anyway, they're recognised as a key threatening process. But is this their fault, or is it a symptom of the landscapes that we're doing? So long-term monitoring has allowed us to test this. So we published a paper from this, which, you know, David likes me to say that it's very important that we keep publishing papers, we go through the peer review. And we have a very simple conceptual diagram from this. So what we did here was reduce grazing, and which changes the vegetation structure, which changes the woodland birds, as from the previous study. But it also changes the noisy miners, which also impact the woodland birds. It's a very simple conceptual diagram that we were able to test. And the first thing we tested was the effect of various variables on the noisy miner. So this is another herendogram, which is an effect size plot. So you've got the dashed line down the middle, and effects to the left, they represent negative effects on noisy miners, and effects to the right represent positive effects on noisy miners. So as you can see here, saplings, which is what we use to measure understory vegetation, the thickness, the dense bush, they have a negative effect on noisy miners. Noisy miners hate that stuff. But stems, over 50 centimetres, that's what we what represents trees, noisy miners love. So even worse herendogram. So this is all the responses of small woodland birds, or all birds, against the noisy miners. So you have against the y-axis you have the effect of noisy miners against woodland birds, and the dashed horizontal line above that you have a positive effect, and below the dashed horizontal line you have a negative effect. So as you can see, as many of you might know your small woodland birds, the birds towards the bottom tend to be the smaller ones, but also, as you see on the x-axis, the small woodland birds are responding positively to sapling count. So what this essentially tells us is that small woodland birds respond positively to saplings, but negatively to noisy miners. And from this, we can infer that small birds like plantings, noisy miners dislike plantings, noisy miners don't harass small birds in dense plantings quite as much, but this intervention can take over 8 years to manifest itself, which sort of represents how important it is for monitoring to be undertaken continuously over a long period of time. So the overarching story of this is tackle these despots with vegetation, not guns. And which intervention is best? Replanting, grazing control, or miner control? It seems to be planting and native regen, and reducing grazing in those plantings as well. And how were we able to tell this? Well, good long-term monitoring that quantifies biodiversity response over long time periods, over large areas, and quantifies the effects of management interventions with adequate controls and treatments, and then attention to reporting those results and analysing those results in a robust statistical manner. So the overarching story for the whole thing, I'm trying to say, is that monitoring is hard work, but it should not be an afterthought. You need a good, strong conceptual diagram. You need key questions to be posed a priori before you actually undertake the monitoring. You need a good experimental design, experimental survey, and you need the infrastructure and methods to undertake the data collection. Now, Sustainable Farms, we have a very strong group of ecologists out in the field collecting data year-long, engaging with the community, and we've been doing that for many years. And we need to analyse those data in a robust statistical manner, and we need to put this stuff through peer review to really get it tested. So in David's recent book, book on monitoring in 2014, he states a rule of thumb. He reckons 10% of the budget of management programs should be dedicated to monitoring effectiveness of programs, and it should be done from the start and should not be an afterthought. Thank you.
Thanks for that, John. Very thought-provoking talk there. I've got a set of questions written down for you. I think in the interest of time and to give other people the opportunity to ask questions so that I just don't quiz you for 40 minutes, I think we'll move through onto Aimee now, if that's all right. As I say, feel free to add any questions in the app. Aimee, over to you.
Hi everyone, thanks for having me. It's a pleasure to be here. My name's Aimee and I am a conservation ecologist with the Tasmanian Land Conservancy, and I'm going to be sharing with you today a case study that we undertook where we compared 3 different vegetation monitoring techniques. But before I start, I would also like to acknowledge the traditional owners on which we meet today, the Ngunnawal people, and the traditional owners on the land which we work, the Palawa people. For thousands of years, they have cared for and protected the land on which we work, and I would like to pay my respects to their elders past, present and emerging. So I promised I wouldn't use acronyms. Here's my first, TLC. Tasmanian Land Conservancy. If you're not familiar with us, just a little bit of background. We're a not-for-profit that protects nature on private land in Lutruwita, Tasmania. From humble beginnings about 20 years ago, we now manage 26 permanent reserves across Tasmania, and you can see them on this map in the blue dots. And we also facilitate protection of nature on other private land through a number of different programs, some of which I've been talking about in other forums today. And Wild Tracker should be on that list as well. I work in the science team, and our main goal is to maintain and improve biodiversity, and we're mostly working on our permanent reserves. And we undertake a number of activities to meet that goal, including monitoring. So this is what I'm going to be focusing on today, our ecological monitoring program. So there's 2 main components. We have a long-term monitoring program that's surveillance-based. So for this, we are trying to monitor and detect the status and trends of conservation targets that we've identified for each reserve. And we also have a targeted monitoring program, and this is where we look more closely at conservation targets that we've identified as priorities, such as threatened species. So the challenge we face, which many of you would be familiar with, is we have a really large reserve estate, and we are managing it with a very small team. So to roll out monitoring across all of our reserves on a regular basis means that our monitoring methods needs to be a balance between being efficient, so quick and easy to roll out, cheap and potentially to be able to include non-experts. However, it's really important that it's worthwhile and that we're capturing what's there and it's fit for purpose. So we had an opportunity when we were establishing monitoring at one of our new reserves and reviewing our vegetation monitoring protocol to trial a few different methods and see how these played out. So just a little bit of background on the three methods we compared, some which you may or may not be familiar with. The first one we used was the Tasmanian statewide method for measuring vegetation condition, which I'm going to be referring to as the TasVeg VCA, so Vegetation Condition Assessment. This method was developed by our State Department of the Environment, and it was based on a method that was used in Victoria, which you may be familiar with. It includes two different components. So there's a desktop component, GIS component, and also a site condition score, which is based on a field component. So the field component is based on a 1 hectare plot, and you're measuring a whole lot of different vegetation components such as canopy cover, species richness, and so on. And these different components are scored against a benchmark for that community. The second method is our method that we started off with, which was our TLC's photo point methodology. This method, we had permanent sites set up in different vegetation communities at each reserve, and we would take photos, a ground photo, an understory photo, and canopy photo, as well as a 360-degree photo. And then we would take these photos back into the office and we would analyse those same vegetation components from the photographs, such as canopy cover or understory cover. And then these were also compared against the statewide benchmarks. And the final method we compared was our proposed new methodology. So I'm calling it the modified VCA, Modified Vegetation Condition Assessment. And this method was based on a defined area using plots and transects. And we were scoring those same vegetation components that I've talked about in the other two methods and scored again against a benchmark. So just to really make the point, the difference between the statewide method and our proposed modified method is that defined space. So rather than using large hectare searches, we're using smaller quadrats, and we're trying to replace large observer estimates over large areas for more discrete objective measures. So we went out onto our reserve and we trialled all three methods. They were undertaken by the same people, and we were really interested in how long this took, what was the effort, and also what were we getting out of it. So this finding was fairly straightforward, and as we'd expect, the more complex your methods, the longer it takes. So our photo points were taking about 20 minutes per site, whereas our other methodologies were taking about 3 times as long, so about an hour and a half to complete this at each site. We're then looking at what data we were getting from each result. And in this graph, each row represents a different vegetation community, and each colour is a different monitoring method. And you can see that we're capturing different components better or worse depending on the method. So our photo point methodology was missing large trees. And we're also getting different data about our understory components depending on the methodology. And if you drill into this understory component a little bit more, this graph shows on the left the lifeform cover measures. And this arrow is pointing at the obvious life forms. You probably can't read that there, but this is shrubs. And you can see that there's a difference in shrub cover depending on the measure. And also the second arrow is pointing at herb cover. So basically our photo points were not very good at picking up these small life forms. Species richness This also, we've generally found that species richness increased depending on the complexity of the monitoring method and the area searched, which also makes sense. We also did some statistical analysis on replicates required to detect change. And if you look at the graph, basically we were seeing how many replicates we would need to determine a 5-point score change in our VCA score. So therefore saying it's gone from 80 to 75. And these are just in different vegetation communities at one of our properties. And also how many replicates you'd need to detect a 50% change in our dominant life form cover. So how much of a medium tussock grass we have. Does it go from 40 to 20%? And basically the takeaway here is the modified methods, which are in the pink, compared to the photo points, they're much lower. So you need less replicates to detect that same amount of change using the more complicated methods. So a very simple summary. Basically, this shows that our photo point method, although it's fast and simple to do, it's lacking in some of those components. Whereas our modified method and the TasVeg VCA, the data is better for what we're using it for. And the modified VCA is using more objective measures. So to conclude, our case study, it shows that you get different results depending on the methodology you use. And the more survey effort you put in, the more vegetation components that we captured, and that methodology was better at detecting change. I think this really highlights that it's really important that we review and analyse the methodologies we're using, and we look into the detail and understand the capacity of our monitoring methods, and continue to reassess if it's fit for purpose, and acknowledge, and this has already been talked about, that monitoring something complex well does take effort. Thank you.
Thank you very much, Aimee. When I was a PhD student, I got told that the mark of a good speaker was someone who could say what they wanted to in exactly the right amount of time, and to do it with 3 seconds is as precise as I've ever seen. So thank you so much. Shawn, over to you.
Thank you, Martin, and thank you, Aimee. I actually really enjoyed that. A really solid sort of analysis of some methods and an evidence-based approach. So hi everyone, my name is Shawn Capararo. I work for the New South Wales Biodiversity Conservation Trust. I'm really lucky to work with a team of very skilled people who are providing some leadership within the New South Wales Biodiversity Conservation Trust in areas of ecology, spatial science, agreement governance and administration. Our team really works behind the scenes and we sort of describe ourselves as a bit of an engine room of the BCT. We're very much in this space of providing sort of leadership across the organisation for how to approach monitoring and assessment, but also providing service to staff across the organisation for doing their jobs. So today I'm going to be talking about BCT's approach to collection and management and reporting of ecological data. It's sort of one aspect of what we do, but a very important part of it. Firstly, a little bit about the Biodiversity Conservation Trust. We're a statutory not-for-profit body established in 2017 under the New South Wales Biodiversity Conservation Act. We've got partnerships with landowners and established more than 2,300 agreements across New South Wales. which is roughly around 2.8% of New South Wales, protected under private land conservation agreements. The real value that the BCT brings is the security of protection. These agreements are registered on title and run with the land, so if the land is unsold, the protection remains. The number and the demand for agreements continues to grow in New South Wales, and new agreements come to us through a range of mechanisms, from those that are established to offset development and as conditions of development consent. We provide incentive funding through competitive tenders and fixed price offer programs. We also revolve land. We purchase land, put covenants on them and on-sell them. And of course, one of the big areas is landowners that are motivated to volunteer and put their land under protection. So the BCT provides ongoing support to these agreement holders, including advice on management, assuring that these landowners complying with the conditions of their agreement and undertaking a lot of the ecological monitoring. Importantly, our field staff are at the front line when it comes to a lot of the assessment, support, monitoring and compliance. And the types of staff that we have that are doing that include ecologists and landholder support officers. And we do also have consultants that come in and support us as well. And it's really the work of these people that my team supports. And I guess these are very busy people, and our goal is really to reduce the administrative burden so that these people can spend more time monitoring, more time engaging with landowners. So it's really important that we can coordinate their efforts and the work that they do and ensure that it has a big impact. So I'm glad we're starting to talk about data. I think there's been a lot of conversation at very high levels. So BCT is actually a really significant creator of new biodiversity knowledge in New South Wales, and I'm not going to go through all of the content up there, but it gives a flavour of the types of information that the BCT is creating and capturing. It's actually really refreshing to work for an organisation that creates primary data and provides information and insights about biodiversity. We're actually got a fairly ambitious goal. Like we're building a network of long-term ecological monitoring sites on private land, and we're actually on track to have established 1,500 permanent plots by the end of this year. So that's a really significant contribution in New South Wales. This ecological information provides the evidence that justifies our investment in land protection, and it sort of demonstrates BCT's commitment to ongoing monitoring. But that commitment does, there is a cost in us investing in that, and fieldwork is very expensive, and we have a sense of responsibility, I guess, to ensure that the information that we're collecting is of high quality, it's trusted, it's looked after, and it feeds into processes where it can actually have a maximum impact. I like to think that, there's two enduring legacies of the organisation that I work for, and so when I'm dead and gone, and all of the people I work with are gone, there will be something that survives, and that is one, the land that's under protection. And the second one that's a significant legacy is the knowledge created from that biodiversity data. So, yeah. So there's three real things that I think summarise what's important to BCT's approach. Firstly, it's about standards. I was actually quite tempted to say that the three most important things are standards, standards and standards, but and it's quite important to everything we do, and important to ensuring that everyone is working towards the same end goal. when I talk about standards, I'm talking broadly about consistent methods, standardised data structures, and governance arrangements for caring for and looking after a lot of our data. The second point is an understanding about how data moves and flows, and some of the snags that can occur, which slow us down, cost us money, cost us time. And the third bit that I think is important is the technology that we use. And the important thing is not being wowed by new technology, but trying to take advantage of what is on offer, and ensuring that it's fit for purpose. And yeah, it's not the technology that's driving, it's not the tail wagging the dog. So. Okay, so just the theme of this conference is really uniting for nature, and the best way to achieve this is having, through the adoption of consistent standards for monitoring and reporting. The framework that sets the standard for the BCT is our ecological monitoring module, which is available on our website. The EMM prescribes the methods, but also provides guidance on priorities and how much monitoring we actually should be doing. It's consistent with New South Wales, other approaches in New South Wales, so the biodiversity assessment methodology, which focuses on vegetation and uses vegetation integrity or condition as a surrogate measure for biodiversity. I guess the importance about what we do under the EMM is it extends the basic methods to make it more sensitive to condition, vegetation condition. The other important thing, I guess, to comment on is that recently BCT has received accreditation from the Accounting for Nature framework for its method, how we actually collect, combine that data and draw conclusions from it. And that method is also available from the website, Accounting for Nature website. Just to focus on the second point about the importance of how data flows. Quite often the biggest time suck for a lot of our staff is moving between different stages in the data lifecycle. By taking a bit of a high-level approach, perspective, we can highlight where there are snags or pain points in how data moves. So BCT has been using integrated mobile tools, cloud data storage and web apps for about 4 years now, and it's brought us enormous benefits in terms of less manual data handling and better data quality. More recently, we've introduced analytical engines for generating trusted statistics about our agreements, and enabled us to build reporting tools that are generating greater efficiencies for our staff. Just a short, this is probably where I lose half the audience, just a short kind of focus on the technology that we use. It's really important that you get the technology right. We use a lot of technologies that are out of the box. There's no dependence on developers. We find that there is a cost. We're not advocating any one technology over another, but we do use ArcGIS Online quite heavily. It works well for us, and the costs of some of the software does offset some of the manual handling that's involved in data. And that some of the tools are well integrated. I'll probably just jump to the next one. And probably just a little demonstration of a short video. The thing that brings a lot of this data together is information that's collected in the field is instantly available to assessors when they come back to their desk. They can visualise it through a lot of the web applications that we've developed, which provide a really seamless workflow for a lot of our assessors. And I'm just about there. Okay, just in summary, some key points. An efficient implementation of our approach requires a really partnership between our field staff and a central group that coordinating their efforts. Field staff collect data according to standards and processes. We do have a very strong learning and development program to build the capacity of staff, ensure that they are complying with some of those standards. Some of the tools need to be simple, fit for purpose. We need to treat data as an important asset. It needs some governance arrangements, it needs to be curated, and quality needs to be controlled. And that allows us to use that data for multiple end uses, and we're finding that in New South Wales, a lot of our data is BCT's data that's been collected under our ecological monitoring program is in demand for use for vegetation classification and mapping, updating vegetation condition benchmarks, and validating models for things like the statewide Biodiversity Indicator program. So, yeah. Thank you, Martin.
Thanks, Shawn. That was great. I can see we're going to have to catch up about a lot of your technology because that sounds fascinating. Lovely. And John, over to you. Thanks so much.
Thank you, everybody. So we know about the nature crisis, biodiversity crisis, and we know that we need as much money in the tin as possible, and we need to invest in nature. And the question I want to ask is, what information do investors need to feel confident to invest in biodiversity conservation? Yesterday, the Minister said we can't kick this can down the road anymore. So what I want to do is pick up this can and have a good look at it and wonder why it's not on a shelf in a market somewhere where customers are saying, oh, yeah, I'm confident to buy that. I want some nature repair. That's a good thing. And so I really want to look at the trade-offs involved for giving the information that markets need to function to get more money operating. And I'll give you an example of the monitoring tool that my colleague Chris Orrick, who's here, working with Nurrinjeri people in our local country, and I have pulled together. In the old days, it was all done with fieldwork, and I'm not suggesting for a minute that fieldwork's not important. It's absolutely critical, and the last two speakers have given really good examples. In fact, all three of the speakers so far have emphasised the importance of calibrated, validated fieldwork, and we fully support that. But there isn't enough ecologists and money and time to do field work on every single project across the whole of the country if we're going to get 30 by 30 up and running. So we need some trade-offs. And as Aimee said, there's one trade-off between quality and cost. And there's also, now with technology, a trade-off between signal and noise. So what we're trying to do with our method is find the balance in those trade-offs so that the information can be provided to the market to give it confidence, to maintain market integrity, but speed up the pace of change to get where we need to for 30 by 30. So there's the cost-quality trade-off that Aimee's already talked about, so I won't repeat that. There's also this signal-noise problem. We've got technology now that allows us to produce vast quantities of data very, very fast, but the question is how much of it is actually useful and how do you analyse it and present it to the market? So the label on the tin says, yes, trust me, buy me. And so there's a temporal dimension to that. Biodiversity changes slowly. We don't need to be measuring stuff every week, every month, sometimes even every year. So we don't need frequent data necessarily. We need quality data in the right sort of latency. Spectrally, there's all sorts of stuff now, hyperspectral, multispectral, LiDAR, drones. What do we actually need to convince the market? That will depend on the nature of the investment. Low risk, low cost projects where we're using established methods that we have trust in, we probably don't need to have lots and lots of fancy tech. If there's offsets included in the nature repair market, hope they're not, but if they are, then that should be monitored in the most expensive, most rigorous way, because we want to make sure there's the smallest amount of net biodiversity loss possible. In between, there may be new methods which are still risky, or very large value projects, tens of millions of dollars, where more monitoring is relevant. And it goes a bit back to what John was saying about allocating a percentage of the total project budget, the management budget, to monitoring. If you've got small projects, that number is quite small. So you need a technique that's more realistic, and this is what we've developed. So Chris and our Narrandjeri colleagues and I have basically got two dimensions to this monitoring tool. One is we're comparing a treatment site where we're doing our work with a calibrated, validated reference site where which is representative of the condition we want to arrive at through our management work. So a comparison element of the monitoring system. The other is that we're looking at a spectral profile using multispectral data from the visual range through to the shortwave infrared range. I'll talk about that a bit in a minute. This is my place here. It's the Fleurieu Peninsula Swamp, and you can see on there we've identified three areas. There's a reference site, which is pristine swamp, which has been studied to death. There's 2 PhDs on it. It's very well understood. There's a treatment site where we're removing Phragmites australis and replacing it with swamp vegetation, and there's a degraded site which is still covered with frag. So what we're doing is looking at the distribution of reflectances across those bandwidths from visual, where we get all the different plant species and so on with their different coloured leaves and all the rest of it, the near-infrared bands with the biophysical properties, leaf area index, biomass and so on, and the shortwave infrared reflectances, which is cellulose and lignin and the non-photosynthetic vegetation. So that spectral profile is produced for the reference site and for the treatment site, and statistically those two profiles are compared. And the further apart they are, the less alike they are. So we can say this site's severely degraded, its spectral profile is very different from the profile of the reference site. This approach complements, for biodiversity conservation, it complements two other techniques which are well established. There's normalised difference vegetation index, NDVI, which tells you how much green stuff you've got, doesn't tell you anything about biodiversity, and the what's on the screen now, which is a fractional cover estimation. It's a Geoscience Australia algorithm, and that's very useful for demonstrating additionality to the market, which is another thing the market needs to know. You know, what are you doing in addition to what would have happened anyway? And on this site, we can see where the Phragmites australis has become established, and it's just sitting there, and then right at the end you can see where my management interventions started to kick in, and that pattern has been disrupted, the Phragmites has been removed, and we've got native stuff coming back. And then what we do at different points in time is compare those two curves, the reference curve, the treatment curve, the statistical analysis of variation between those two curves. And this is actual data. Swamps change fast compared to other ecosystems, so these are a year apart, but you can see on the left-hand side a big difference between the two sites, the treatment and the reference site, but then after a year of hard work, a convergence of those two curves, and the photo points, which we also use, demonstrate that visually, and we've also done species counts and other things to back up the method. So what you can see there is a very simple, relatively cheap, we're talking, hundreds of dollars per site, maybe low, $1,500 rather than tens of thousands of dollars. Chris has done the hard work with the algorithms and the coding, but it's a method that works for a large number of projects in the sort of market we're going to have in Australia. So where I'm aiming for with monitoring is to get a new label on the tin. I want nature repair soup to be as trustworthy and as comforting as a tin of tomato soup. We want to be able to demonstrate with monitoring data additionality, we've already got the tools to do that, adequacy of progress, the tool that Chris and I have developed helps with that, variance from plan, that supports management. You know, if we plan to get somewhere and it took us a bit longer, why? If we're not on track, why? That's useful for internal management. We want to be able to demonstrate the outputs we've delivered from our management and the biodiversity outcomes, the so what question. And if we can bung that on the label, I think people will start to get more confidence in what we've got to offer. Happy to answer questions. Ethel there, Kidner from Yundi, she's very supportive. Email addresses for Chris and myself. Chris is up the back there, happy to answer questions. But I'd encourage you to think about what information does the market need to have confidence to invest in what we're all trying to do so that we can get this normalised and more happening on the ground. Thank you very much. I've got 7 seconds left.
Lovely, thank you, John. And thank you to all our speakers, actually. As someone who spends most of his time in an office, it's actually really nice to hear again about people doing real work, in a sense. So look, we have 14 minutes left for questions. As I've said, feel free to shout them out if you want, but also put them in the app. If I could start, though, just because I've got the microphone. It seems to me that the common thread here is we're trying to, through monitoring, describe a complex and changing world is as simply and as at low cost as possible. So are there limits to the sort of inference we can achieve from monitoring programs? Are we ever going to be able to say with certainty at low cost the state of an environment and therefore be able to price it effectively? Is science pushing us forward in that regard, or are the limits to what we can say? If it's all right, I might start with Aimee, if that's okay. I'll put you on the spot.
Thanks, Martin. I don't have all the answers. I don't know if anyone does. And it's really great to talk to other organisations and see that we're all working on this problem and there's some alignment to where we're getting. But I think, as John started at the beginning, it's really important that we continually reevaluate the fundamental point of our monitoring. What's the question? What are we measuring? How do we measure it? And is it giving us what we need? And depending on the complexity, it's going to take different levels of monitoring, I think, is the outcome that I've come to at the moment.
No worries. Shawn, you're working at quite a large scale across a lot of New South Wales. Does that change the shape of the solution, or is it simply a case of things that work at one place work well at others?
I think it is a consideration, Martin, and probably one of the things that's reflected in our approach is, ecology is very complex. There are many opportunities, I guess, for monitoring a range of different parameters, and for us, I guess what it means is that there is in order to have a common and unified approach, there is probably a level of simplicity built into our methods, and in order to make them standardised so that we can draw conclusions, and I guess that's reflected in our our ecological monitoring module does actually cover a range of different parameters and things that we want to focus on. But at the core, there is a focus on vegetation and vegetation condition as a common and unifying element that we look at. So, yeah.
John Evans, if I could come back to you and not let you off the hook from having simply spoken first. We've been talking a bit at this conference, well, I don't know if others have, about things such as the nature repair market. You've advocated in this talk that that elements that are not simply what you observe at a site are relevant, such as the design of your study and the appropriate statistical approach for analysing it. Do you think there's a challenge there for how to design monitoring that works at a site level but still gives inference?
Yes, there is a challenge. I think when you're working at the site level, I think there are so many different variables to take into consideration that impact what is actually going on. I suppose what I'm advocating for is a adequate replication that an action will have an outcome given a context. But then there are lots of things that will be out of the control of a landowner, for example, that, you know, they could be placed next to a car park or something, so they won't get the species that, you know, they intend to try and restore for. So I suppose the replication over at a landscape scale within a certain vegetation type or community is important to know, so that error can be taken into consideration when there's an action. Is that kind of what you mean, or?
Yeah, I guess it's we trained in the same university at the same time, so perhaps this is a little confounded, but we were taught, you know, elements of statistical design are critical.
Yeah.
But there is a challenge in having a reference and a control for every site. I guess what I'm saying is if you're trying to have a market, that's a little bit different from designing a scientific study, potentially.
Yeah, that's true. I suppose I quite liked the utility of what John was talking about with the spectral stuff, but at the same time you still need to have a grounding of what's actually supposed to happen on the ground. But you can't obviously go and, you know, do a control and treatment site for every single farm that's in the nature repair market. But you can get a good idea. You still need strong replication and design at a certain number to be able to get an idea of what the overall effect might be if you do an action. And then you can compare that to more technologically advanced techniques to see what is actually happening. And I think that's kind of what John was saying, really.
Yeah, John, it sounds like you've been doing a lot of that calibration. Do you want to respond?
Well, I go back to the market. What does the market need? The market needs confidence that the theory of change is robust, and that's where the research comes in. I think research and performance monitoring are two different things. I mean, they're complementary, but they're two different things. So we need good research to give confidence that a method, a land conservation, nature repair method, will deliver the outcomes expected. And then the project intervention, the job is to, you know, say, here's the method we're going to use, this is what we plan, this is the adequacy of progress, this is the change seen, and based on the research at other sites and based on the comparison with a reference site for our treatment site, we have confidence not only that the biodiversity outcomes will be delivered, but also that our progress is adequate. That's what investors want to hear. So you need the two things, that the underpinning science is robust and logical. That's the sort of work you're doing. And then that the investor project, building on that science, is delivering the potential that the science says is there. So I think there's two different things.
No, fair point. We've had a question from the audience, thanks, Kate, which is a difficult one but builds on this same question, which is how confident are we that what is being monitored is truly representative of biodiversity? And I guess it comes to that question of what your surrogate is that you measure and how that reflects other change. Do you think that's a challenge we can ever truly resolve or get close enough to?
Look, you never know what's there unless you're there every single day. And just on my swamp, I can tell you, you can do the spectral stuff and you can say, yep, the the 80 or 90 plant species, their reflectance is roughly similar to the reference site, but the yellow-bellied swamp skinks that are very rare that live there, if you don't see one that day, you won't record it, but if it'll be there tomorrow. All those sorts of things, emu wrens, there's all sorts of things. So I think you need both, the detailed stuff, particularly the reference site, for calibration, validation, and then just use the ecological assumption that, and it's a bit like what Shawn's been doing, if you look at the plant community as that key, part of the ecosystem that drives everything, you can start to make assumptions about other biota, the vertebrates and the invertebrates and all the rest of it. And then from the reference site, which is calibrated and validated with a lot of field studies, you can start to assume if we've got this plant community, then we may have these reptiles, these amphibians, these birds, these insects, etc.
Yeah, thank you. Aimee, if I could go back to you, your talk, you mentioned a combination of vegetation monitoring and targeted species monitoring. Is it challenging in the context that this theory of change that we were talking about, where we assume that changes in vegetation flow on to changes in animals, and John discussed that as well. Is that something you find, and other challenges in prioritising plant and animal monitoring efforts?
I focused on vegetation monitoring, I suppose, because that's my role in the organisation. We also have a person of my role that focuses on fauna, so we also have an extensive fauna monitoring program. So yes, apologies for that, don't forget the other side. But we work as a team, and when we acquire a new reserve, we look at all of the records and we go onto the site and we map what's there, and then we sit down and we identify what the key targets are that we're looking for, both vegetation and fauna. And that's how we identify what we're monitoring for. And importantly, we are an applied organisation, so monitoring is there to inform management interventions. So we're definitely picking out aspects that we can have some influence on.
No worries. We've had another question from the audience, and specifically for Shawn. And it's a question about the fact that you work with landholders. Do you ever feed information back to your landholders to keep them informed of what you're finding on their properties, and how do they respond?
Great question. There is, obvious need to inform, feedback, and I guess express gratitude to landowners for the privilege of actually being on land that they manage and control. We do have a mechanism where we provide information back to landholders through, a standardised site values report, which is a summary. It's actually feeds into some of the flow of information that I was trying to communicate, that we are trying to make more efficient with the large numbers of landowners that we're supporting. There is a risk of staff spending a lot of time preparing reports that are tailored for landowners, and we're trying to look at mechanisms to make that more efficient. So we have developed some approaches which is drawing on the data that is collectively pooled in order to generate a more streamlined summary report that does go back to landowners. But I do think that is an important element that we're going to have to continue to maintain. So VCT's been in this business for now for 5 years, and we have seen a growth in landowners that have come to us. We've provided information based on some baseline assessment and work that we've done, but as we go back in the future, revisit those properties, there is going to be a need for that constant engagement, communication with the landowners about what we found and how their particular agreement is performing. I think it is a big demand. Individual landowners want to know what they're looking after is how it stacks up, and how it's performing. So.
No worries, thanks so much. Look, we're about at time, so I'd love to keep talking, but I think we'll have to take it outside and do that over lunch. All of our speakers, thanks so much for coming, but also for sharing your insights. It's been genuinely a learning exercise for me to hear about all the exciting work that's going on. And please join me in thanking our panel today.